Example 1 here on modelling exponential growth and decay is taking a look at sketching an exponential graph. And we're asked to sketch y equals e to the 3x plus 2 minus 11, marking any asymptotes and intersections with the axes. Now to start here, we should just be able to identify straight away what this shape will look like. So this is an exponential graph, and what we can notice here is if we write this in the form y equals e to the ax plus b, and then we've got our plus c here. Okay. Now for our example here of y equals e to the 3x plus 2 minus 11, we notice that a is positive. So in that case, we will have the shape that looks something like this. Okay, it's going to look something like this. Okay, all we need to identify now is the asymptotes and the intersections with the axes. So if we want to find the x-intercept here, so to find the x-intercept, then we need to be aware that the x-intercept is when y is equal to 0. And in that case, we can easily find this by using the idea that the natural logarithm of minus c and then minus b here all over a gives us our x-intercept here. Okay, but again, you could easily set y here and then solve for x there in that case. The y-intercept here is given when x equals 0. So this one's rather straightforward. If you set x equal to 0 here, all we simply obtain then is that the y-intercept here, and what I should have done here, set this x equals this expression. So I set it here, that's x equals. So for this one then, this will be y equals e to the b plus c there, okay? Because all we've done here is made x equal to 0, so in that case we just get left with e to the b plus c there. And finally for the asymptote here, so for the asymptote, well in this case the asymptote is simply given by y equals c here. Okay, now let's find each one of these points. So the first one here is my x-intercept. Well, in that case we just need to substitute c, b and a appropriately into this formula. So therefore, just do it slightly above here, x is going to be equal to the natural logarithm of minus c. Well, in our case, if we write this down, a is 3, b is 2, and c is minus 11 there. So in that case, if we take the natural logarithm of minus 11, then that's the natural logarithm of 11. Okay. We now minus b here, where b is 2, so that's minus 2, and this is all over a. Okay. Remember, a is just 3, so that gives us our x-intercept. And for now, we'll keep everything in exact form. However, when we come to sketch this, clearly we will need a rough point here. Y then, we just need to simply substitute b and c into this formula here. So therefore, y is given by e to the b, where b is 2, so that's e squared, plus c, where c is minus 11. So e squared minus 11 gives us our y-intercept. And finally, our asymptote here is given by y equals c. So therefore, in that case, as c is minus 11, our asymptote is y equals minus 11. And if we sketch this here, we should get something of this form. Again, we've got this shape here, as we denoted above, and we can easily identify the x-intercept. That's the natural logarithm of 11 minus 2 divided by 3, giving us 0.133. We have the y-intercept given by e squared minus 11, which is minus 3.61. And finally, we have our asymptote here of y equals minus 11. So we just get that there, y equals minus 11 there. Okay, and we can identify that here by this grey dotted line at the bottom. Okay, so that's what we should get there for our sketch, giving us the solution to example 1. Example 2 here on modelling exponential growth and decay is taking a look at sketching a logarithmic graph. And in this example, we're asked to sketch y equals the natural logarithm of 6x plus 5. And again, we just want to mark any asymptotes and intersections with the axes. So here again, in this case, first let's identify the shape of this graph. So it's the natural logarithm here, and again, let's just denote the general form here. So this can be y equals the natural logarithm of ax plus b. Okay, and again, a is positive, so what we would expect here we just draw a rough sketch. It's something that's going to have this general form. Yeah, it's got this rough shape to it. Obviously, it'll cut through at different points what we're indicating here, but it's going to look something like that. And again, what we need here is simply the X-Intercept, the Y-Intercept, and the asymptote that we have here. Well, the X-Intercept is simply given using the following formula. And again, this would simply be obtained by setting y equals to 0 and then solving for x. So the X-Intercept here, given by x equals 1 minus b all over a. Okay, so that gives us the X-Intercept there. And again, we'll denote the Y-Intercept and the asymptote first, and then we'll evaluate each one separately. So the Y-Intercept now, well, in this case here, this would be obtained by setting x equals to 0. So in that case, sorry, that would be y equals here. Well, if you set x equal to 0 here, then all you simply obtain is y equals the natural logarithm of b. So that's nice and straightforward. And then finally, we just have the asymptote here, which in this case is going to be x equals, for our asymptote in this occasion, it's going to be minus b over a. So that's the formula we use when finding the asymptote here for the natural logarithm, a logarithmic graph. So minus b over a there. Okay, so let's just quickly get rid of this smudge in here. There we go. And now let's move on to sketching this. So we've already identified the shape that we should obtain here for our logarithmic graph. In that case, we just need to simply work out the x-intercept, the y-intercept, and the asymptote. Well, in that case, the x-intercept here is simply given by using the fact that a is 6 and b is 5. So in this case, this is 1 minus 5 divided by 6. And that will give us minus 4 over 6, which is equal to minus 2 over 3 there. For the y-intercept, well, y equals the natural logarithm of b here. So in that case, the natural logarithm of b is simply going to be the natural logarithm of 5. So let's just go to that y, sorry, here. We go to that y. So in that case, it's just simply equal to the natural logarithm of 5 here. Okay, because b is 5. And then finally, our asymptote here, x equals minus b over a. Well, in that case, we simply obtain minus 5 over 6 there. And what you should get here is something that looks like this. Again, we've got the correct shape here, as we identified above. And we can clearly see our y-intercept here at y equals the natural logarithm of 5, and our x-intercept here at x equals 1 minus 5 over 6, giving us minus 2 over 3 there. And finally, we also have our asymptote here at x equals minus 5 over 6. So that gives us our solution there to example 2 on sketching a logarithmic graph.